Hi, and welcome to another episode of Mysteries of Science. My name's Dan, and I'm the editor of Science+Nature magazine. It's a monthly magazine from the team behind The Week Junior.
And I'm Kieran, the features editor. In every issue of Science+Nature, we explore the entire universe through in-depth features, news stories, images, interviews with top experts, and much more.
Hi, and welcome to another episode of Mysteries of Science. My name's Dan, and I'm the editor.
Wait a minute, didn't we just hear that?
Yeah, that's strange. I'm sure I've heard this before. I'll tell you what, I'm getting a feeling of deja vu.
What's that?
Deja vu's that kind of funny feeling you sometimes get when you're absolutely convinced you're reliving something that's already happened. As ever on this podcast, we're going to dive deep into one of our favourite mysteries of science this week. These are the strange phenomena and bizarre events that have left scientists scratching their heads and, despite all of their best attempts, remain well and truly unsolved and unexplained.
Deja vu is a brilliant example of that because it's something we probably all felt for ourselves, but the science behind it is still somewhat mysterious. Over the years, there have been all sorts of theories about why you might feel as though you've lived through a situation before, and we're going to look at every single one.
That means we're going to have to investigate dreams, ghosts, and the inner workings of our brains. This is a unique sort of mystery, a kind of one-of-a-kind episode. What I'm trying to say is, even though we're chatting deja vu, you've never heard anything like this before. This is Mysteries of Science.
Deja vu is a term that not everyone will be familiar with, so let's take a moment to break it down. It's a French phrase which translates to already seen, and as an example of it, a few weeks ago I was sitting on my laptop chatting with a friend and they started to talk about a new job. I was sure we'd had that conversation before, me sitting exactly where I was, them saying exactly the same thing, but it had to be deja vu because they'd only got the job that day.
So this is something quite different to doing something that you've already done before. It's not the same as a routine or familiar thing. You probably won't get a sense of deja vu every time you get into your same old car seat or go the same route to school or, say, eat your favourite meal. Deja vu is much more specific than that. It's the eerie sensation of living through the exact same moment for the second time.
Unlike ASMR, which we spoke about in the last episode, deja vu is something that affects most people. It's thought that between 3 or 4 people out of every 5 get hit by a wave of deja vu on occasion. Annoyingly for scientists, though, there's no way of knowing when the next bout of deja vu is about to happen.
Yeah, it's really hard to study, basically because you can't really induce it, and a lot of neuroscience, when you want to test something experimentally, means kind of getting that to manifest in a controlled manner. And deja vu, by its very core, is that it's difficult because it's just so fleeting and random, so it could happen at any time.
Say hi to Dr. Amy Reifelt, a neuroscientist and senior lecturer at the University of Adelaide in Australia. For those who don't know, neuroscience is the study of the body's nervous system, so that's the complex combination of nerves and senses, which includes your brain and spinal cord.
There's going to be a fair bit of chat about neurons today, given that deja vu affects how we think and what we remember. So we asked Amy to explain exactly what they are.
So your brain cells, or neurons, are the cells in your brain that are able to fire together by making electrical signals, and these carry information around your brain between different regions of the brain that are involved in different functions. So it can be, there's regions of the brain that are involved in controlling behavior, and there are regions of the brain that are involved in making memories and updating memories and different forms of motor control and memory. So yeah, neurons are the key cells within the brain.
Amy's been researching deja vu, and particularly what's going on inside somebody's brain when they experience that typical wave of deja vu. Before we get too technical, though, it's important to know that one of the main theories around how memories work suggests that there are two ways of remembering something. And this is important because déjà vu affects your memory.
Amy had a really great way of explaining this theory of two different ways to remember something. So, imagine you're in an exam and all the questions are about the Mysteries of Science podcast. What a great exam. The first question is, how brilliant is the podcast? And your optional answers are A, very good, B, exceptionally good, and C, exceptionally very, very, very brilliant and ace. Now, even if you've not listened to the podcast in a while, you will have a general memory that it was C. But then, the next question is to give the name of the first expert who spoke on the Aliens episode. Now, your general memory can't help you there. You either have the specific recollection of who it was, or you don't. And for those of you who are wondering, it was the astronaut Ed Gibson. 10 points if you remembered that.
So there are these two memory systems, and they operate out of separate parts of the brain. The first is the rhinal cortex in the temporal lobe. So the temporal lobe is a large part of the brain that sits on either side of the head. And it's what stores general information that helped you to answer question 1. For question 2, you needed that very detailed specific memory, which is stored away safely in a part of the brain called the hippocampus. And this is part of the subcortex that lies deep inside the brain.
Why does all this matter? Well, one of the big theories around déjà vu is that it is caused by your brain accidentally plucking up memories from the wrong places. So say you're chatting to a friend that you chat to all the time, your rhinal cortex might activate and send out that wave of general familiarity, but you might not get any specific recollections. This would make you feel as though you're really, really properly recognising and remembering something, but you don't have any of the details to hand. That's how it feels when you have déjà vu. Something is very recognisable about the situation, but it also feels slightly off.
Okay, that's a whole lot of brain talk, and brain talk can be super confusing, and it's making my brain hurt a little bit. So let's take a little break from my brain and chat about something much easier to understand, shall we? How about ghosts?
We can't just start a new mystery mid-episode, Dan.
Ghosts, spirit worlds, past lives, all of these seem to have a connection with déjà vu. So I guess the thinking went that déjà vu was being caused by living through something that a ghost or a spirit had warned you about. Or maybe it was a message from another dimension, or an experience that you had in another life. Of course, as far as science can show, ghosts aren't real. So why do people think they are?
Well, I'm Christopher Lloyd, and just to remind everybody, I'm a world history author. I'm passionate about connecting the dots of the past and connecting subjects together, and I believe that the real world is far more amazing than anything you can make up. If you go back 500 million years into the oceans, the first creatures that we know of really to develop focused eyesight are trilobites in the oceans in the Cambrian period. Now, if you can see the world around you, suddenly you need a different type of brain to survive, because not only do you need to be able to see what you need to eat for your lunch, which requires a very focused, precise type of calculation. You can see in front of you a little worm or something. You've got to work out where it is. You've got to swim towards it. You've got to coordinate your muscles. You've got to catch that worm before it runs away or wriggles away under the ground. You know, it requires a lot of concentration. But at the same time, there might be another creature with eyes behind you that's going to sneak up on you and have you for its lunch. Now, that is no good, because if you have just one form of consciousness that's targeted and precise to find your lunch, but then you get eaten by somebody else as their lunch, it's game over. So you don't have one brain, you have two brains. And I think a lot of the research, early research in the 1960s into the brain, was looked at this idea of the right and the left side of the brain, and how we have these two different operating systems, if you like. One, the left side of the brain that's focused on what's right in front of us to try and make sure we can coordinate and solve a problem, which is, what am I going to get for my lunch? And then the other brain, which isn't interested in that, it's only interested in the unknown. It's interested in what's around us, the big picture. What other things are there out there that might be a threat to us? And I think in a way, the paranormal is an expression of that other form of consciousness that we've slightly lost sight of, I think, in our enthusiasm to understand ourselves, because that's all very left brain, isn't it, really, to try and understand, what our brains are doing and what they're made of. It's very focused and precise. But there's this other part of us that's evolved over hundreds of millions of years to try and reach out and connect the dots of all the unknowns, that hears voices and that sees things that may be hallucinations, and that believes in things that there's no evidence for them being there. Maybe that's the most natural thing of all. Maybe that's something that's evolved simply as a survival strategy in a world with creatures that have eyes. So at that level, in some ways, I think it's quite easy to sort of explain.
Dan, I thought we were having a break from brain talk. Although credit to Christopher, that did actually make sense, even if it did set off my inner "where's my lunch" alarm.
Yeah, Christopher's point is just a really important one, because although deja vu might feel weird and strange and mystical, it just isn't. It's fully rooted in science. But there is a catch, of course, and Christopher explains that figuring it out is much easier said than done. And before we head into this next clip, all you need to know is that an fMRI machine tracks blood flow in somebody's brain in real time, and this reveals where activity is happening.
There are some really interesting things beginning to emerge, where some scientists believe that they can detect, tell what you're dreaming just by looking at the fMRI scans of the brain. Or they can tell maybe what you're thinking, or maybe they can create an interface between your thoughts and a computer. So if you think about a cursor on a screen moving upwards, don't say anything, don't touch anything, don't do anything. Just the blood flows that creates can send a message, via a scanner to your computer, which will move the cursor up the screen.
It feels like everyone is warning us that this brain business is a bit tricky. But will that stop us? Not likely.
Not likely. We know that deja vu is caused by events in the brain, and as we mentioned earlier, this may be because your brain is plucking memories from all over the shop, and that makes you feel disorientated and strange.
Right, and that might suggest that there's some sort of mishap or misfire in the rhinal cortex, which, as we remember, is the area of the brain that deals with general familiarity as opposed to specific recollection.
Kieran, you said earlier that most people never know when deja vu is going to strike. But some people do. If you have a condition called epilepsy, which causes sudden bursts of brain activity and uncontrollable shaking, you can actually predict the next wave of deja vu with a little bit of notice.
That's because people with epilepsy have a high chance of experiencing deja vu just before this spike in brain activity. So scientists can look at what happens inside those people's brains and therefore get a very accurate picture of brain activity mid-deja vu.
Hey, guess what they found out when they did this? The signals of deja vu are normally found in the rhinal cortex.
That's a big thumbs up for our theory that it comes from those feelings of general memory as opposed to specifics, and that there's some sort of mishap there.
Yeah, but it is worth pointing out that some scientists think that the type of deja vu experienced by people with epilepsy might be somehow different to the deja vu that everyone else feels.
So it's a breakthrough of sorts then. There's definitely something going on inside our brains that triggers deja vu. There's no question about that. And there's a good chance that it comes down to some sort of activity within the rhinal cortex. Ultimately, though, there are lots of questions that are still to be answered.
There is a lot that's happening, but, and this is a big but, and I'm reminded here of a cartoon, a Snoopy cartoon, a Peanuts cartoon, where Charlie Brown is looking at the moon, and he takes a step forward, and Snoopy says, "What are you doing, Charlie Brown?" And Charlie Brown says, "Oh, I just wanted to get a closer look." And in many ways, I think that's a bit like us and the brain, We think we're taking a big step forward, but actually, we can't really see anything because it's so complicated. It's so incredibly difficult for us to get inside. And just as you explained, it's a bit like Charlie Brown, taking one step closer to the moon to try and get a better view,
Taking a look at anything related to the brain just feels exactly like Charlie Brown trying to get a better view of the moon. It's also complicated that every breakthrough offers only a tiny improvement in our understanding.
I've studied memory for many years, and from what I've learned along the way and studied along the way is that there's lots that can go wrong in the brain when there's so many millions of neurons that are all firing in their very distinct rhythms, and to make our brain waves and to make our memories.
Oh dear. Amy, you've confirmed our worst fears on this podcast. I think we may have hit a brick wall here. Deja vu, are you an unsolvable mystery? Is there simply too much to know about our brains that we don't understand, and too many possibilities for errors to slip in? How are we ever going to identify precisely what causes deja vu?
It's a good question, Dan. We still don't know why deja vu is triggered, or even whether it's intentional or an error in the brain. Why do some people feel its effect more strongly than others? There's still a lot that we need to understand, and the more we try to spot the tiny hidden clues that are inside our brains, the harder that job might become.
Well, our investigation has taken us deep inside our brains, but we've come back perhaps without a fully convincing explanation. But I'm determined to end this episode on a positive note. So what can we say? Perhaps scientists are struggling to wrap their brains around the exact causes of deja vu, but they are much closer, and recent advances have revealed much more than we knew before.
We're definitely on the way to a solution. As ever, we want to hear from all of you listening. Have you experienced deja vu before? What happened? What brain fact melts your mind? We're collecting all of your contributions for an episode that will come at the end of this series, where we answer your questions, read out your comments, and listen in to your brilliant feedback. So, email hello@science-nature.co.uk to tell us what you think, either by writing it down in an email or recording your thoughts on a short video or audio clip and sending it in to us.
I've just realised we got to the end of this episode without another classic deja vu joke where we say the same thing over and over.
Okay, we need to fix that before we go. How about this? Email hello@science-nature.co.uk to tell us what you think, either by writing it down in an email. Classic lols.
Now, remember to rate and review this podcast wherever you listen to it, and subscribe or follow so that you never miss another episode. Now, remember to rate and review this podcast wherever you listen to it.
Don't forget to pick up the latest copy of the Week Junior's Science and Nature magazine for even more mysteries of science.
We'll be back in 2 weeks with another monster mystery. Look out! What's that I hear coming over the hill, crashing through the forest? Oh no, it's only the sound of North America's most famous ape, Bigfoot. Let's hope he doesn't hear us. Until then,
stay curious.
If you want to get your hands on a copy of the Week Junior magazine, we're offering a 6-week free trial. To get yours, head over to dennismags.co.uk /The Week Junior and use the code PODCAST.